So today we're going to be looking at graphene. Graphene is a material that you all will have heard of, I'm sure. It's been in the news a lot recently, and it has some remarkable properties which we're going to look at in some detail. I want to cover the history of graphene and briefly outline how it's produced. But just to start, what actually is graphene? Well, graphene is the name given to a sheet of graphite which is only one atom thick. And as you know, graphite is a form of carbon with a layered structure. And graphene is only one layer thick. So that's the first thing to note, that it's an incredibly thin material. And because it's so thin, it's very flexible, but also extremely strong and chemically stable. It's also highly conductive. That is to say, it conducts heat very effectively, so it has a lot going for it. Graphene was first discovered by the German chemist Hans Peter Boehm and his team in 1961. But it wasn't developed further into the beginning of this century, so around 2000, 2004. A number of scientists had recognized the potential, the possibilities of graphene. One of them was the physicist Andre Geim of Manchester University in the UK. His vision for the new material was to use it to make foldable computing devices, computers, or smartphones with screens that you could bend and fold. His thinking was that this would have significant benefits from a commercial perspective, because using graphene, you could produce a flexible smartphone or tablet that is almost unbreakable, which is pretty amazing when you think about it. Historically, graphene was difficult to isolate. It wasn't until 2004 that Andre Geim and his team discovered a simple way to produce it. The technique they used is known as mechanical exfoliation. What they did was, they began with a 25 millimeter thick piece of graphite and started to split it horizontally to make it thinner. So this process involved repeatedly dividing the graphite layer by layer until only one layer remained. Now, Geim's technique is very successful at producing small amounts of high-quality graphene. However, for many businesses, mechanical exfoliation is not really satisfactory, because it's very difficult to manufacture large quantities of graphene using this process. In practical terms, it just takes too long to produce graphene in this way. More recently, a research team at Northwestern University in the United States have begun to use a different method for developing graphene. They hope to produce larger quantities of graphene using a more industrial process so that it can be used to create new products. The Northwestern process involves breaking down graphite chemically in a liquid solution. What the researchers did was to add graphite to an ethanol-based liquid, so an alcohol-based liquid. And they observed very small, very thin pieces of graphene beginning to flake off from the graphite. They then mixed these graphene flakes into printer ink and put the ink into a normal inkjet printer. From a commercial perspective, this represents a much better solution. It means that industries can print graphene electronic circuits onto any surface, a flexible plastic screen, pieces of clothing, paper, and so on. I mean, imagine, for example, a large screen that can fold like a map into something you could put in your pocket.
Right, okay, so this morning I want to talk about a material, a building material, from a range of perspectives. The material I've chosen is something that we see every day. It affects the way we travel, the way we work, and the cities that we live in. It's probably all around us at this very moment. So, I'm talking about concrete. Technically, concrete is defined as a composite material of water and coarse granular material embedded in a hard matrix. And of course, it's something that we are all familiar with. Historically, it has been the main building material for large-scale construction. In fact, the earliest large-scale users of concrete were the ancient Romans. Both the Colosseum and the Dome of the Pantheon in Rome are actually made of concrete. Although it was used less after the end of the Roman Empire, construction work in the mid-18th century was often influenced by Roman design, and this helped concrete to become popular again. Today, concrete is, by weight, the most widely used man-made material. The largest sector of the concrete market, ready-mix, is worth approximately $100 billion. So, in that respect, it's been commercially very successful. In practical terms, concrete is a versatile substance. You can build quickly with it, it's strong, and it lasts a long time. For example, the Assyrian Jawan Aqueduct, which is made of waterproof concrete, was built in 688 BCE. There are, however, some environmental impacts. Producing and transporting concrete uses a lot of energy. It also uses a lot of water, which we all know is a precious natural resource. And finally, there's the question of what it looks like. A lot of people would say that visually, concrete isn't very attractive. And it's true that many concrete buildings are not very beautiful to look at. I mean, look at the university library for a start. But perhaps that says more about the architects than the building material.